Okay, let's go over a few attacks before we get into it, just so you can see how dangerous this can be and how you can, or someone can perform some of this, and then how you can defend against it. Now, the first one that we want to cover is the session hijacking attack. Okay, now I'm over here in one of the browsers logged in to Netflix. Okay, and again, this is just a regular Netflix. And what the attack is going to try to do is going to show what happens if someone gets access to a user session and how they can take over their identity on the web. Okay, so I'm going to go ahead and open up the console, and then we're going to go over to the application server, the application tab on our server, and then we are going to, so again, remember, on the left side, we're logged in. On the right side, we are on an incognito window. Okay, so we're definitely not logged in, and it has nothing to do with the account on the left side. But what we're gonna do is over here, we're gonna come, and then we're gonna grab these two cookies that Netflix has set, and then what we're gonna do is we're going to just copy them over into this other Netflix account. And again, let me just refresh this account so you can see that I am not logged in, right? So although we have these two cookies, this is not an actual valid, this is not a logged in account, whereas on the left side, we are logged in. So I'm gonna go ahead and just grab these two cookies, okay? And then I'm gonna paste it. I'm gonna paste the first one, and then I'm gonna paste the second one, okay? Perfect. And now what I'm gonna do is I'm gonna refresh this page on the right side, and let's see what happens. So as you can see, now on the right side, okay, without actually knowing what this user's, let me just pause this, without actually knowing what the user on the left's login info is, okay, all we had access to was their cookies. And on the right side, if someone were to inject some malicious code, and if someone were to pass this information around into their server or get their hands on it, then you can see how they can, you know, in this example, we showed something pretty benign, which is just logging into a Netflix account. But you can imagine how this can be used to either log in into your Gmail or a bank account, or even some company information. So again, these are this is what happens with session hijacking attacks. And in this course now, what we're going to be doing is we're going to be covering the defenses and how this attack actually takes place. Now I want to show you another attack just so I really want to drive home the importance of protecting, you know, not just your identity online, but your users' identities online if you're a developer. So over here, we're going to do something very similar. So on the left-hand side, I'm going to make this window just a little bigger, okay? And then I'm going to bring this down. So on this page, okay, we have two servers running. Now I'm going to go ahead and show you the code. One is the victim server, and then the other one's the attacker server. And what we're going to show is we're going to demo, imagine if on one side we had a secure bank, you know, imagine this was a bank, and on the right side, we have an attacker that was able to implement not just a session hijacking account, but through the cookies, they're able to post a form to the server, to the victim server, and because the victim is logged in on one or their accounts, then they can perform actions on behalf of the user. So let's see how that works. So, and again, one of the things we want to make sure that that we're looking at is over here we're actually logged into two servers. Okay. So this is a cross-site scripting attack, and we're going to cover this more in detail in the class. But you know, you don't have to be logged into the same server at all. So imagine these are two completely different servers, okay? And then what I'm going to do is I'm going to go ahead and what we're going to do, it's over here. We're going to log in as if we were a user of this bank, okay? And we can see that that again, just like a normal bank. You have your balance, and then you have this form over here that you can transfer money to someone else, okay? Now, the attacker, what they've done is they have actually, imagine if someone gave you a link, or if someone was able to get you to click on a link that gets you to a different website. Now, once you're on that different website, imagine that this form was actually hidden, okay? Now, we're showing it not hidden over here to showcase the example, but this will be on a different site, and the user wouldn't even know that this would be actually happening. And with JavaScript, we can actually automate this whole process. So over here, we have a client that's logged in, or at some point they're logged in. So they have a session running with within their bank, okay? and now they've kind of clicked away from that bank, and now they're on to another site. And on that site that the attacker sent, that the attacker has hidden this form, okay? And what they're going to do is we're going to perform the attack just so you can see how it happens. So I'm going to go ahead and transfer $500 to another. Let's say in this case, we're logged in to we're going to use the Alice user cookies to send $500 to Bob. Okay, and then we're going to go ahead and click on transfer. Okay, and again, imagine if this was hidden. So this is not something that's actually taking place with the user knowing. And then what we're going to do is we're going to refresh the actual bank website. So next time Alex comes and logs into their account, they're going to see that their balance is 0. And what we've done is that we have actually, okay, and if we check over here on the network tab, we have actually performed an attack, and I'm going to refresh it. Okay, and because this person at a previous time, they were logged in into the, let me go over here and then log in into the network tab. So you can see, so yeah, over here in the network tab. So because this website, and actually what we want to do is just click on the application tab just so we can see the cookies, and then over here as well. Okay, so because this attacker has access to this session ID, okay, and then the session ID is not protected in any way, anytime someone on any other website, okay, as long as the session ID is valid, okay, and the attacker, if we look over here at the attacker form, okay, we can see that they're making a request, a post request to this localhost 4000, which is where the bank website is hosted. Okay, now when they make the request, since this person was actually at some point, and this request again can come from any website. You don't have to be logged in. It doesn't even have to be from the same bank account. This is just the way the web works, okay? And how cookies work. And what I'm going to show you is how you can defend against this attack. But because of this, okay, any request, okay, that gets made to this server over here, okay, what the website is going to do and what the client's going to do is it's going to include any of the cookies that are on that machine. And in this case, right? Because this although it's the same user and we have this cookie, but we're on a different website, then when we actually go ahead and make the transfer amount, okay, we're gonna go ahead and see that the transfer got made, and not just the transfer get made, but included with the transfer, okay, we have actually gone ahead and included the session cookie, okay, even though over here we don't have any access to it, okay, because we're on a different domain. It got included because at some point that user also had logged in into their bank account. So again, these are two ways that session hacking can happen, and I wanted to go over the attacks. And now what we're going to do is we're going to go ahead and set up the attack, see how it works, and see why it works and how we can defend against it. Okay, now that we have gone over the session hack, now that we've gone over the session hijacking attack, what we want to do is we want to understand how did that attack happen, what about the web makes it vulnerable, and how we can defend against that attack. So what's the first thing, okay, when we talk about the web, what exactly happens when you type in a URL, okay? And that's the first thing we need to understand, and that happens at the DNS level. Okay, so the domain name system, and that's what the DNS is, okay? So anytime that we're on our computer and we're typing a URL on the URL search input, okay, so if you go to Google and you type in a URL or something like that, what's going to happen is a few things are going to happen. Every URL that you type in gets forwarded, okay, or gets translated into an actual IP address, okay? But at first, we don't know what that IP address is. So let's say you're going to example.com, okay? So the DNS resolver, which is usually issued to you by your ISP or a router or something like that, this DNS resolver, it's recursive. And the first thing it's going to do is it's going to say, hey, from your computer, you're going to say, I want access to example.com. So you're going to go from the 1 to the 7 over here, okay? But the first thing is the DNS resolver doesn't actually, is not in control, or doesn't know what that IP address is. So it's like, okay, I see that you want to go to example.com, but first I need to know where that's located. And I don't know where that's located. So the first thing I'm going to do is I'm going to ask a root server. And the root server is going to come back and tell you, is like, I don't really know where that is either, okay? So what's the root server, what's their functionality? Well, the root server's functionality is to accept recursive resolver's query, which includes the domain name, okay? and the name servers respond by directing a recursive resolver to the TLD server. So what the recursive server is doing at this point, the root server is going to say, hey, I can see that you're trying to access a .com domain or a .net or .edu or whatever, and it's going to tell you, why don't you go and ask the TLD server? Okay, so it's going to send you and going to redirect your DNS resolver to a TLD server. Now, the function of a TLD server is to maintain information for all the domain names that share a common domain extension. So a .com or a .net or whatever comes. So it's going to start from the right to the left. Okay, so once we get issued from the TLD server, it's going to tell us, okay, you got the .com, okay, but I still don't know that where example.com is. Okay, so I'm going to go ahead and send you to an authoritative name server, and the authoritative domain server is now that we have the TLD extension and that we have taken that IP, okay, where this is going to be located. Now we have everything we need in order to ask the authoritative domain server what the IP address of this specific URL that we're trying to access is. And the authoritative domain server contains information about a specific domain name it serves, right? So it can provide a recursive resolver with the IP address for that server found on the DNS record. Now, if a domain has a CNAME record, it will provide the recursive resolver with an alias domain, at which point the recursive resolver will have to perform the whole DNS lookup to procure a record from the authoritative name server. So all this really means is, at this point, now that we have the authoritative domain server, in this case, example.com, is going to come back to us and say, hey, I'm example.com, I'm the authoritative name server, and I actually know what the IP address of example.com is. So now we can actually translate that that the way it was written, which is human readable, right, example.com, into the 1.1.1.1 IP address that we're looking for. So essentially, what happens when you type a URL and press enter, just to recap, is that the client has the DNS recursive resolver to look up a hostname, okay? That DNS recursive resolver sends a DNS query to a root name server, okay? Now, the root name server responds with the IP address of the TLD name server, okay? The DNS recursive resolver sends DNS query to TLD name server, okay? So now that we have the root name server, okay, which again keeps a record of all the TLD name servers, and then after that, the TLD name server is going to send us to a DNS recursive resolver to an authoritative domain, and that authoritative domain is going to come back with the full IP address of the domain we requested, okay? And that's how a DNS domain name system works, and that's the first step, okay, in any query that happens on the internet. And that's important to keep track, okay? That's important to understand because if you remember at the beginning of this class, we talked about how browsers work, okay? Now we're going into how the network works. And the first step, okay, from your browser to the internet and to access any of the files, any of the resources that are hosted on the internet, this is the first step. So it's going to go over our DNS resolver, okay? Now, your DNS is usually something that it's like a router, or if you're, let's say, on a Starbucks location or at a coffee shop or somewhere public that you log into a Wi-Fi network, then they have a DNS that you know, anytime your query comes in, right, it'll go through their DNS resolver, and then they'll bring back to you what the actual IP address. So all the DNS resolvers work in exactly the same way. They go to the root server, TLD server, and then the authoritative name server, and then they return back to the user the actual resource that the user asked for at that point. So let's talk about really quick some of the attacks that happen at the DNS level, okay, which is at the very, very low level of our first interaction with the web. So the first one is DNS spoofing. So let's think about how this happens. Let's say you are at a public coffee shop, okay? And then someone, an attacker over here, injects a fake DNS entry, right? So whenever we're going to go ask the DNS, hey, where's example.com? The DNS server is going to say, hey, I know where that is. And it's going to point back maybe to a client that the attacker controls, okay? And then what the attacker is going to do, they're going to request whatever the client requested on their behalf to the real website, and then what they're going to do is they're going to return that back to the client. But because the attacker has inputted themselves in the middle, okay, they can spoof that address that they get back from the DNS, so that real IP address, they can spoof it and say, hey, you know what the IP address is? It's me again. So because the attacker is going to say, hey, it's me again, next time we go and ask for something back from the DNS, it's not going to go to the real website, which is what the DNS should have resolved. It's going to go to the attacker website. And at that point, the attacker can clone the website, not just clone it, but then inject code into their into that DNS entry, into that resource that they got from the real website, and then return it back to you. But what the client doesn't know is that this attacker in the middle, they have actually injected some code that didn't come from the real website. It came from a fake website. And that's what DNS spoofing is, okay? And that's what we need to be really careful when we log in into public Wi-Fi's. This is something that a lot of people do. So if you should be careful. And there are tools to check the DNS spoofing. Now, again, if you're in a reputable place and you know this place, it's not so much of a thing to worry about. But this is the first place where attackers come and something where they can start injecting code into your code base, right? So again, DNS spoofing is just cache poisoning. So the DNS, once it resolves an IP address, it caches it, okay? So the next time we're gonna go ahead and ask other resources from this real website, it's just gonna say, hey, I know where that is, but it's gonna go to the attacker because the attacker spoofed their IP address and say, hey, I'm the IP address, okay? But now the attacker knows what the real IP address is, but you don't, right? So then they can perform all the requests on your behalf, and at that point, then they can inject any code on the website. So the next one is DNS tunneling. So DNS tunneling is a little bit different than DNS hijacking. So what happens is, let's say you're on premise, right? So you're behind a firewall of some kind, right? So you have a business, and but there is a computer that logs into the network of that business, maybe a VPN or something. And what happens is, as we're sending packets over the web, so as we're sending information over to we're asking resources online, so we're going to different websites, we're going to maybe log into a Dropbox or a Gmail or any other website that you log in. As those requests are going out, we can attach packets to the request, right? So the packets are what's going to be encrypted and then decrypted at the other end of this website. So if you're sending traffic over HTTPS, this all the traffic is it's pretty much encrypted at that point, and it's secure. But if someone is in your network and has some malware, then they can use the DNS as a transport layer, which is not what it's intended to be. But because DNSs perform so many queries, then they can attach to each of the queries a little packet that actually gets out of the network and then goes to an attacker's infrastructure. And once the attacker has that information, then they can extract information from inside the premise, or pretty much at that point, it's a vulnerability attack, and any data that the attacker set up on the infected machine can come through the DNS as a transport layer, and the attacker can get access to it. Okay, another attack that we want. This is one that we just went over, and it's pretty similar to DNS spoofing, but whereas DNS spoofing and DNS hijacking, where they differ, is that DNS spoofing actually attacks the cache of the DNS, right? So if you remember, when we perform our DNS resolver, the resolver at the end, once it gets the IP, is going to say, hey, next time you ask for the same example.com website, I'm not going to go through the whole song and dance, right? So it's not going to go through every step of the going over to the TLD, the root server, and then the authoritative name server. It's just going to look at its cache first, and it's like, oh, I already know what this is, so I don't need to go through all that, and then it's going to return the resource, right? It's going to just return the IP address. So that's where DNS spoofing, the attacker attacks the cache. In DNS hijacking, the attacker does not attack the cache, but instead it injects himself or herself in the middle, and then every single time someone asks for a resource, is going to say, hey, I'm that resource, and then it's going to perform that request on behalf of the user, and then return whatever the user wants. So it's very similar to DNS spoofing, except that it's happening for multiple domains. So this could be something that if actually happens, then that attacker could essentially snoop on the traffic, on all the traffic going through that network, and then they can do whatever they need to do, or whatever they want to do to the response of the user. Now the next one The next is NX domain attack. So the NX domain attack, this is not so much about injecting code on a to a user and the response. This is more, let's say your business hosts a website, right? Maybe like PayPal or something like that, or any other website for that matter. What the attacker is going to do is they're going to do a denial of service attack. So they're going to inundate the DNS server, okay, with requests. So now that they have access and they know the IP address of the DNS server, they're going to ask it for records that don't exist, okay, in an attempt to cause the denial of service for legitimate traffic. So although there is although most of the people that are going to that website are just regular requests, there are these other requests that are very hard to detect the difference within the DNS, because they look just like regular requests. But the difference is that these denial of service attacks, they're asking for resources that are not in the server. So because they're asking for resources that are not in the server, when the DNS tries to resolve that, it takes a lot longer than when it actually finds a resource, right? Because it's going to look, and then it's going to look through the whole kind of map of that whole website. So depending how big that website is, this can take, a way longer for that response to happen. And then because it's a denial of service attack, it can even be distributed. So if it's distributed, then that DNS for whatever that URL is going to get then inundated with fake traffic. And when a regular request comes in, then they're not going to be able to get the response back, and it's going to either time out or or it's going to be a denial of service on the host access, and you won't be able to respond with an actual with your actual website, right? And that's how the attack takes place. And the phantom domain attack, the main difference is the attacker sets up a bunch of phantom domain servers, right? Which either request very slowly or not at all. They're going to ask for resources that they know are on the server that take up a lot of, so let's say it's a 3 megabyte file, right? It's a 3 megabyte image or something. So what they're going to do is they're going to request that image multiple times, thousands, millions of times, depending how they set it up, the attack. And then they're going to try to make the same attack, which is denial of service. And this is, this can happen for companies, big companies. Maybe you've heard in the news how companies are getting hacked. This is one of the attacks that someone might perform on the DNS at the DNS level. And then the botnet attack, getting any one of these attacks and then creating an automation for them. So a bunch of bots or a bunch of servers that once we have access to the DNS and the actual IP addresses, then we can just go ahead and automate all that. And instead of coming from one machine, right, and trying to inject code, then the attack will come from many machines. And essentially is going to try to overwhelm the host server. And then the host server is either going to create a denial of service, so it won't be able to host itself,